Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from LexisNexis. We have Charles Kaminski, who is a senior architect at the company. Charles, welcome to the show today.
Rich, thanks for having me.
You bet. Now, Charles, we're here today to talk about big data and the solution that LexisNexis brings to the table. It's called HPCC. Can you tell us more about that?
Sure. But if I could for just a moment, many of your listeners may not be familiar with LexisNexis or why we even have a solution around high-performance computing or data-intensive computing. So LexisNexis, for more than 35 years, has been a big data company, even before big data was really in the press so much as it is today. And for those past 35 years, we've been living and breathing many of the same hurdles that many of your listeners may be trying to overcome at this moment. But also, we have been living the solutions as well. And for the past 10 years, we've been using a technology that we call internally the HPCC, or the High Performance Computing Cluster. And most recently, we created a group within LexisNexis Risk Solutions called HPCC Systems. And just recently, we open sourced that technology as well. So the message to your listeners is the same technology that we've been using for the past 10 years to run multi-billion-dollar businesses is now available to them as an open source solution. So big data to us doesn't mean big teams or complex systems. To us, big data we solve these big data problems with a single cohesive solution that is made up of three components. We call it the Thor, which allows us to do ETL and data transformation, and the Roxy, which allows us to do data delivery. And those are put together cohesively through a single language called ECL, which is a highly efficient language. It's a declarative language that allows us to focus on the business problems or the technical problems, the algorithms, and not so much how to implement something on a parallel cluster.
So I guess this looks complicated. It looks like it might be really hard to set up just even to try it. Is that true, or do you have something in mind here?
So so one of the things that we're always working on internally is how to lower those barriers, how to make things simpler and easier to do for our own benefit so that we can get products out the door quickly, but also for the benefit of the community as well. And in general, setting up clusters can be difficult. I'm not talking about the HPCC cluster. I'm talking about any cluster in general. Setting up a single computer can be laborious at times, but now you're talking about a system that may have 50 nodes, 100 nodes, 1,000 nodes in it, and that can be complicated and laborious just in terms of the amount of work required. So one of the things that we did here is we automated much of that process, and we, in working with Amazon, I'm going to a website here now. If you go to hpccsystems.com, that's our main website here. For the platform, but then if you just prepend that with AWS, you'll hit this other portal here. And what that allows any user who has an Amazon account, or if you don't have one, you can get one fairly easily, to just enter something called their access key ID and their secret access key, and at the click of a button, have a Thor cluster available to you. Whether that be a single node system for you to play with, or a 100-node system for you to get some serious enterprise production work done. So I can go ahead and launch a cluster here, and I'll do that just by bringing over some access keys. And you can create as many access keys as you need, create and delete them, so that if you're concerned, I'm not concerned about showing the world this access key, because I can very easily retire it whenever I like. And I can log in here, and immediately the system checks my account in Amazon and reports back what it sees in Amazon and also what it sees here locally. And as you can see, I have a number of nodes running. And when we're ready, we can just go ahead and launch one, and your audience can then see how easy it is to have a Thor cluster of their own.
So I guess let's talk about the Thor component and why that's important, because that's what you're showing us here, right?
Yeah. So for those who were probably watching over the web, they saw me just enter a number 10. I wanted a 10 node system, and the system immediately recognized that I'll need an additional support node. So I'll have an 11 node system. It connected to the U.S. West region, which is Oregon, and it calculated a unique cluster ID for me, and is now launching those nodes on my account.
Very slick.
And then if you come back over here, we can leave this go here for a little bit. It'll only take a moment or two. But if you click back over here to view clusters, you can see we can just look at this 3-node system that I had up running earlier today. It's still up and running. You can go in and you can view the log and see, exactly what happened on the account to bring up the cluster. Go back here. You can look at the config file that we pass in, that we generate dynamically and pass into each of the nodes so that the system knows how to configure itself. The IP addresses. So there's this idea on Amazon of a public and private IP address. And it's important for the user to know what each of those nodes is doing, and if they want to SSH into a node, they can easily do that. And then in order to make all of this magic work, we have to generate an SSH key, a PIM file, so that we can log into the nodes and do what we need to do. But we really want to be hands-off. We don't want to own that. So you can go ahead and download that PIM file so you can SSH into any of the nodes that you need, and delete it off of our system. With the caveat that once it's deleted, it's gone completely. That just make sure that you've downloaded it and stored it in a safe place. I think that's a good segue too to mention that none of the keys that you provide us when we log in and we check your system are stored on the system, and we use encryption, and then we sign cookies to make sure that they're not being tampered with, and then we use those cookies to check to see who you are on the Amazon system and do what we need to do at that time. So security to us is very important as well. We can see here that that 11-node system is still configuring. We have this 11-node system that we just brought up, and the very first thing that you can do is you can go to what we call the ESP page. So I'm just going to go ahead and click on that right there. And you can see up here that it went to that IP address, 50.112.56.107. Each one is going to be unique for the cluster. They're assigned by Amazon. And port 8010. And we can go in here and we can actually run just a little bit of code just to make sure things are up and running. There's no smoke and mirrors or anything along those lines. We can go into my ESP, my ECL direct, and run just a little bit of ECL here. And we just do an output. Hello world. And go ahead and hit submit. And we get a little hello world back. And then, of course, the other thing that we can do is we can open up our ECL IDE, which is what developers use to develop on the platform. And we just need to take note of this IP address here. I'll just bring it up here again. It's right here. So I'll bring up my ECL IDE, go into Preferences, put in that new IP address. Hit OK. And now I'm connected to my cluster and I can run code. And if you go on to our Getting Started page here, see Getting Started. This is just a little bit of code here. It's a little bit more complex than a hello world, so we can see some of the other benefits of using the HPCC. And I can just open up a new ECL file. Go ahead and check the syntax. It comes back with no errors. and then go ahead and submit that to my Thor cluster. And you can see the Thor cluster then goes ahead and compiles the job we've asked it to do. In just a moment here, it'll return back an answer. So here's that code that we ran on that 11-node system. And when the system finishes running it, you can see this little check mark here, and you can go in and see the timings of all the events that that were occurring here. How long it took, the total Thor time, initializing the environment, so on and so forth. And you can click here on the graph, and you can see from a visual perspective exactly what was run with that code. You can zoom in and out here. You can see that we went through what we call a normalize, and we redistributed some data, and then we split that data, and then we did a filter and a join. And then you can see the results of that data over here. This is just, I believe this is just the first 100 records, if I'm not mistaken. Actually, it looks like a bit more than that. So it looks like we probably ran about 1 million records there.
Okay, so just to summarize this demo, you set up a one-click kind of instance of HPCC that someone can try out the environment. You ran an analytics job once the environment was set up, right? Mm-hmm. And you got your results in, what, the space of like 5 minutes?
Yeah, so that's from launch to results. Once you have the system up, you can see it only took about 16 seconds to run through about 10 million records.
Well, Charles, I want to thank you for coming on the show today. It's exciting to see, a robust kind of a solution like this brought into open source and made so accessible through a demo like this. I think you've done a great job.
Thanks, Rich. It's wonderful to chat with other folks who are interested in data-intensive computing, and that's definitely. I think you'll find that throughout our organization. We've been working on this, behind the scenes for so many years. It's just exciting to be able to talk to other folks and engage with them about the various things that are happening out there in the HPC world.
Well, terrific. Well, thanks once again, Charles, for coming on the show, and I'm sure we'll see you soon at some HPC events this year.
Thanks again.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.